Hello everyone. Today we'll be discussing the problem break free which came in starters 93 happened on 7th of June 2023. The problem statement goes as chef has an array A of length n. Let B denote the array obtained by removing any non-empty subset of indices from the array A. The removal of subset of indices is said to be good if the sum of subarray Bij is divisible by 2 for all pairs of I and j varying from 1 to the length of B. Find the number of good removals. Since the answer can be huge, print the modulo of 10 to the power 9 plus 7. And the edge case, that is if there is an empty subarray, its sum is 0 and hence it is divisible by 2. Now the catch is that since every pair of indices I and j are considered, we must make sure that even individual elements are even, as I and j can have a difference of 1, and for any subarray if even one of the element is odd, then it is not possible, then the sum is not even, right? Because that singleton array will have an element which is odd, and hence the sum of that subarray would be odd. So the basic case is that we at least need to separate all the odd numbers, as we have seen in this, as we have removed index 2, that is the number 1 from the array, and the index 0, 1 and 3 in the second one. For all cases, in order to obtain a subarray B such that the every subset of that subarray has an even sum. Let's look at that more closely. For example, let us have A, B, sorry for the handwriting, C, D as A. Okay. Now if let us suppose that A is even and B is odd. Okay, if we don't remove B and we remove A, so there is a removal of A, that is of index 1. Okay, and the left one array subarray B would be B, C, D. If either B, C or D is odd, we can always take a subarray such that it is B, and hence make the say that since B is odd, hence the sum of this subset of B is also odd, and hence it is not a good removal. So we have to at least remove all the odd elements from that from the array A, right? After that, we can one by one remove all the subsets of the even array in order to obtain total number of good removals. For example, if uh, B is odd and ACD is even, so
Also, BA is removed and CD is left as B. That is, whenever I say B, it is the array which is left after a good removal.
okay. More importantly, we can always remove a subset of this array to get a good removal, right? Hence, our answer should be 2 to the power number of even numbers in array A. Okay, but we have to consider an edge case. The edge case is that when there are no odd numbers in array A. In that case, we would be counting one removal in which none of the elements are removed. And since it is invalid as written in the problem statement, that a non-empty subset must be removed from array, we have to consider that as well. I hope that you have understood my thought process behind the solution, and let's see the C++ implementation of the same. Here I have taken n as the number of elements or the size of a answer as a counter to count the number of even numbers, p to find the power of 2 to the power answer, and m to take the modulus of it. Answer counts the number of even numbers, and this loop finds 2 to the power answer. If answer is equals to n, which I have stored in result, then we decrement p by 1 and then again take the modulus of p by m. I, I hope that I was able to convey my solution to you properly. Thank you.